Here are problems 4 and 5 from the 8.3 Day 2 worksheet. Again, you should have your 8.3 Day 1 worksheet, your note packet for reference, and a calculator. You're welcome to follow along, but definitely try plugging these numbers in to make sure we get matching results. Problem 4 on the 8.3 Day 2 worksheet is exactly like problem number 7 on the 8.3 Day 1 worksheet. Going from the iron post to the brook to the old mill, on Trig Trail, and then finally back to the iron post. Now, if we take a look at that picture, or if we start from the beginning, we just want to create an image that represents all of this information. It says, from an iron post, proceed 500 meters northeast to the brook. So northeast is going to be right in the middle of north and east. That means as I create my picture, I'm going to find my starting point and draw my north. Northeast means I'm going to go at a 45-degree angle. So I'll arrow this up, label my angle 45 degrees, and my distance is 500 meters. From there, it says we're going to go 300 meters east along the brook to the old mill. If I draw my north again, we're going to go straight across along the brook until we get to the old mill. And that distance, get a little dot there, is 300 meters. And if it's going due east, we're forming a right angle. Then we go 200 meters south 15 degrees east to a post on Trig Trail. That means if I draw a south instead of a north, we're only going to go 15 degrees east. So that's just a teeny tiny amount for 200 meters. So that's also a smaller segment. Getting to that point on Trig Trail, here's 200 meters, and that angle on the inside is 15 degrees. And then we continue back to the iron post. So we're just going to go straight back. So your picture should look something like this. The question is, what is the distance from the iron post to the old mill? Well, the iron post is where we started. The old mill is directly across where that 15 degrees is. We're looking for that segment in the middle. So there's more information on this picture than we actually need. That 200 on the right isn't going to be super helpful. But what we do need is this angle on the inside of the triangle. To get that, let's go back to our original part of the picture where we went from the iron post to the brook. Notice we've got two norths over there. That means we should be able to figure out this angle at the top. If we take 180 minus 45, that would be 135. That would be the angle on that left-hand side. That's helpful to get the angle inside the triangle, our theta. To get theta, if we take 360 minus the 90 from the due east minus the 135, we actually get 135 left over. That's the angle on the inside. And once you know that angle, we've pretty consistently been using law of cosines to get the length of the opposite side. To get x, we would say law of cosines. We've got that side angle side information set on our picture. To set it up, x squared would equal 500 squared plus 300 squared minus 2 times 500 times 300 times cosine of the angle in between, 135. As usual, type all of that into your calculator at once. Pause the video and actually type it in. Once you're done, press play and we'll continue on. If you plug this in, you actually get a pretty decent sized number for x squared. 552,132.034. To get x by itself, we'll take the square root of all that. To the nearest tenth, the distance from the iron post to the Old Mill is approximately 743.1, and our label for full credit is meters. Problem 5 is the first problem that actually wasn't on the 7-3 day 1 or 7-3-8-3 day 1 worksheet. Taking a look at a map, finding the distances from, or using the distances from Minneapolis to Albany, Phoenix, and back to figure out some bearings. And the key for this one, as I stated in the help video, is that you're going to want to create your north images for each location. So a north here, I'll want a north by Albany, and we'll actually need that north down in Phoenix. Now when we're looking at the bearings, we're going to have to be looking at angle measures. And notice all 3 side lengths are given. When you have SSS, we're going to use the law of cosines. Here's how it's going to work. We want to find the bearing of Minneapolis from Phoenix. So what we're looking for here is ultimately this angle measure, and that's on the outside of the triangle. We can get that angle by using some information on the inside, recognizing in the directions that Minneapolis is west of Albany, so there's no degree change there. We can mark that as a right angle, meaning that's 90 degrees. If we can find the angle on the inside using law of cosines, we could then find that angle on the left, which is which is parallel to the north of the Minneapolis and Phoenix locations. So then we could ultimately subtract from 180 to get our final bearing. That was a lot of information. Let's first find angle M on the inside. So this angle right here. To do that, we're going to do cosine of M equals. So this is law of cosines, finding your angle measure. We do side squared plus side squared minus the opposite side squared. That means I'm going to do 216 squared plus 465 squared. Is that what that says? No, 165. Wow, I was way off. 165, sorry. Minus this segment straight across, 380 or 368 squared. All divided by 2 times 216 times 165. That would give us cosine M equals, in the numerator, it's pretty big, 150, no, not 150. Sorry, I was looking at the wrong part of the picture. In the numerator, if we do 216 squared plus 165 squared minus 368 squared, we're going to get negative 61,543. In the denominator, 2 times 216 times 165 is 71,280. Now to get angle M, we'll take the cosine inverse of this. Negative 61,543 over 71,280. Rounded to the nearest tenth, angle M would equal approximately 149.7 degrees. That would be that angle on the inside. So now what I'm going to do is I'm just going to erase this and write that angle measure in, 149.7 degrees. That's this angle right there. Knowing that the angle from Minneapolis to Albany is a 90-degree angle, we can then find the angle on the left by using 360 and subtracting out the 149.7 and the 90. That would give us just what's left over. 360 minus 149.7 minus 90 is 120.3 degrees. That would be this angle on the left-hand side of Minneapolis, 120.3. And remember, ultimately, our goal is to find the angle in red. What is the bearing of Minneapolis from Phoenix? Our due north then would rotate clockwise to the right. To get that final theta answer, we just have one step left. Remember, those two norths are they're parallel to each other, meaning the two angles on the inside are supplementary. All we need to do now is take 180 minus 120.3. And that will give us a bearing of 59.7 degrees. degrees. That is ultimately the final answer. This one took quite a bit of work. But we're going to apply that kind of same idea in Part B. Part B wants us to find the bearing of Albany from Phoenix. Now what we're going to do to go from Albany, or to Albany, sorry, from Phoenix, is we're going to find that bigger angle. That is going to be our new bearing. Well, we already have part of that answer. Part of the answer is the 059.7. What we need to do is figure out angle P for Phoenix in that triangle, and then we just add them together. So this one's actually a little bit easier than the last one. We're going to do law of cosines again. We'll find the measure of angle P first by doing law of cosines, and then we're going to add the bearing of Phoenix to Minneapolis, and that'll be the bearing to Albany from Phoenix. All right, so we're going to do cosine P for Phoenix, which seems weird because it's P, but it sounds like F, but anyway, you get it. So that means we're going to do side squared plus side squared minus the opposite side squared. This would be 216 squared plus 368 squared minus, directly across, would be 165 squared. All over 2 times 216 times 368. Again, we get big numbers on this one. This is what I was actually talking about in Part A. I was one step ahead of myself. 216 squared plus 368 squared minus 165 squared is a whopping 154,855. Wow. Divided by 158,976. That's what cosine P equals. To get P by itself, we'll take the inverse. Of that big fraction, 154,855 divided by 158,976. We get a pretty small answer, and that should seem reasonable because Phoenix is the side length opposite angle P is the smallest side. But this is kind of a tiny angle. We get approximately 13.1. That's just for that little angle on the inside. Based on that, to get the bearing then, our new theta, we're going to take that 13.1 and simply add 59.7 to it. And you should get 72.8. So 072.8 degrees. And those are questions 4 and 5 from the 8.3 Day 2 worksheet.